Hi everyone, Mr. Boltri here bringing you video 5.4. We're going to talk about how to analyze velocity versus time graphs and acceleration versus time graphs. So first, here is our trusty friend, the velocity versus time graph. So I want to just go through this and talk about the different things that we can analyze about this graph. Let's say first that I ask you to find the instantaneous velocity. Let's just say the instantaneous velocity at 2 seconds. So the way that you would find that is you would just read it off the vertical axis at the appropriate time. So you find 2 seconds and then the velocity, because this is just graphing a bunch of instantaneous velocities at a bunch of different times. So at 2 seconds, the instantaneous velocity is 10 meters per second. That was pretty easy. What if I asked you to find the acceleration? Well, acceleration is defined as how much the velocity changes with respect to time, or how much the velocity changes each 1 second. We've also defined it as the slope of a velocity versus time graph. So to find it, we could calculate the slope. To calculate the slope, you use the same method that we've been using all year. Is you choose 2 points and then calculate the rise over run, or the change in the vertical variable, the y, divided by the change in the horizontal variable, the x. That's going to give us a change in velocity divided by a change in time, which we can simplify to be how much the velocity changes every second. And here's an example of that calculation. So 16 minus 7, that's how much the velocity changes, and 4 minus 1, that's how much the time changes, change in velocity over change in time. We get 9 meters per second, or change in velocity, over the course of 3 seconds, change in time, which means that every 1 second, we could rewrite this as 3 divided by 1, which just means that the velocity changes by 3 meters per second every 1 second. So our answer is 3 meters per second each second, or 3 meters per second squared is also an acceptable unit. So to find the acceleration, we just calculate the slope. To find the displacement, as we talked about in class today, the same thing as unit 2, you still have to find the area between the line and the horizontal axis. So to find the displacement between 0 seconds and 5 seconds, we would find the area between the horizontal axis and our line. So it's going to make this weird trapezoid shape. Sometimes it'll make triangles, sometimes it'll make rectangles, sometimes it'll make trapezoids. So for those of us who have the area of a trapezoid formula memorized from geometry class, you can use that right here, right now, and this will be a really easy area to calculate the shape of. But for those of us who don't have that formula memorized, you can actually break this up into easier shapes, the ones that we know how to find the area of. So I easily know how to find the area of a rectangle and the area of the triangle. So that's exactly what I'm going to do. I'm going to break this up into a rectangle and find the area of that, and a triangle, find the area of that, and then add them together to get the total area of the shape, because the area of a velocity versus time graph gives us the displacement. And last but not least, if I ask you to find the average velocity, we are going to use the same average velocity formula that we figured out in unit 2, which is the average velocity is the change in position over the change in time. And don't forget, change in position is just another way to say displacement. So first of all, you're going to have to find the displacement by finding the area, and then just divide by the change in time. And that is all of the things that I'm going to ask you to do when analyzing a velocity versus time graph. Ooh, with one exception, sometimes when we get a velocity versus time graph, I might ask you to make for me an acceleration versus time graph based on this velocity versus time graph. So to do that, we have to remember that acceleration is the slope of a velocity versus time graph, and just find the slope of this velocity versus time graph at a bunch of points. Let's say I go to 1 second and try to find the slope of this little segment. So I actually do the math, and I found that it was 3 meters per second each second. So then I could go and I could calculate the slope at 2 seconds, 3 seconds, 4 seconds. But you'll notice something about this graph is that the slope as time goes on is not changing, which means that if we calculate the acceleration a bunch of different times, it's not going to change. And we can represent the constant acceleration as a horizontal line at 3 meters per second each second on my acceleration versus time graph. So that is how you would make an acceleration versus time graph based on a velocity versus time graph. And then we might want to analyze our acceleration versus time graph. So the vertical intercept is just going to be the acceleration at 0 seconds, which we just say is the initial acceleration. The slope of this graph, you'll notice the slope of this graph is 0. What that means is that as time goes on, the acceleration is not changing. If the slope of this graph were anything other than 0, it would be how much the acceleration changes each second. However, you'll notice that this unit is called constant acceleration. So all of our acceleration versus time graphs are going to have a slope of 0. We are not going to deal with changing acceleration with respect to time, because in order to do that involves knowledge of calculus. But if that is something that interests you, then I highly encourage you to take AP physics along with AP calculus, because then we can analyze acceleration versus time graphs with non-constant acceleration. Just a fun little trivia fact to slip in there. The rate of change of acceleration with respect to time, there's a fun vocabulary word for that, which is called jerk. So in this class, we're going to have 0 jerk in all of our problems. But the AP exam can be a real jerk about some of their problems, and they sometimes do have changing acceleration. Then sometimes we try to find the area of graphs. And the meaning of the area of an acceleration versus time graph is actually the thinker question that I'd like to end this video with. So I would like for you to find the area of this segment and then look at the units and try to figure out what the area of an acceleration versus time graph means. We will begin our next class by talking about what you think is the meaning of the area of an acceleration versus time graph. But for now, this is Mr. Boltri wrapping up video 5.4 on VT and AT graphical analysis, and go Bears.